In this video, we're going to use integration by substitution to integrate these three. So to integrate the first one, you're looking for something out there in such a way that when you differentiate it, it gives you this. And notice that if you look at e to the power of x squared, when you differentiate this x squared, when you differentiate x squared, it gives you 2x, which is this 2x here. So the trick to using integration by substitution is to notice that 2x is a derivative of x squared. So let's start again here. You're looking for something out there in such a way that when you differentiate it, it gives you this. Make this to be your initial guess. Your initial guess should be this. So imagine this as being a bubble. When you differentiate this, when you differentiate e to the power of x, it would be e to the power of x. So when you differentiate this, it would be e to the power of the bubble. And then you times the derivative of the bubble itself, 2x. So now tidy this up. So when you differentiate it, it gives you 2x e to the power of x squared, which is exactly the same as this. So the answer to this is well, it is e to the power of x squared, because when you differentiate it, it gives you the exact same thing. So the answer would be e to the power of x squared plus c. That's your answer. Now let's look at this thing here. You're supposed to look at this as the trick to doing this is to visualize this as being one block, and then you've got a fraction over here, 1 over x squared plus 1 squared. And then you can rewrite this as being x squared plus 1 to the power of negative 2. So you can imagine this as being x squared plus 1 to the power of negative 2 dx. So when you come to integrate this, notice that if you look at the bubble, when you differentiate the bubble, look at the bubble, plus 1. When you differentiate the bubble, it will be 2x, and then when you differentiate the 1, it will be 0. So the point is that you've got an x here, you've got an x here. So when you come to integrate this, make this to be your initial guess. So remember, you're looking for something out there in such a way that when you differentiate it, it gives you this whole thing here. And notice that this is a derivative of this thing. So when you make this to be your initial guess, it's always one notch higher. So your initial guess should be plus 1, and then one notch higher is actually negative 1. Now when you differentiate this, the power comes down, the bubble stays the same, the power gets minus by 1, and then you times the derivative of the bubble itself, which will be 2x. And notice that you've got the x here, and then this thing here to the power of negative 2 is exactly the same as this. So let me just tidy this up. So you've got negative 2x, and then you've got x squared plus 1 to the power of negative 2, which is this bit here is exactly the same as this. You've got an x here, you've got an x here. You just don't want this negative 2. So you would go back here, you would go back to your initial guess, and stick a negative 1 over 2. Now, when you differentiate this, the negative 2 would disappear. And then you want the 4 here. So you would go back to your initial guess and stick a times 4 in here. So now when you differentiate it again, it will then give you a 4. So now it's just a matter of tidying this up, because you've got one block times this block here times this block here. This gets multiplied to the top, giving you negative 2, and then you've got this block here, which will be x squared plus 1 to the power of negative 1. So when you differentiate this thing here, it will give you the exact same thing over here. So the final answer would be, let me just clean this up. The final answer will be the final answer would be, oh, I'm going to visualize this as negative 2 as one block, and then this minus 1, I'm going to visualize it as x squared plus 1, like this. This gets multiplied to the top, so it will be negative 2 over x squared plus 1 plus c. There, that's how you integrate this. So for the last one, notice that this is a bubble here, and if you look at the bubble, when you differentiate the bubble, it will be 2x. You've got your x here. You've got your x here. We can negate this 2 later on. We can make some sort of adjustment. Ignore the constant. You just want this x here. So let's integrate this. So to integrate this, you're looking for something out there in such a way that when you differentiate it, it gives you this. Well, let's make this to be our initial guess, x squared plus 1. So now, when you differentiate this, don't forget this is a bubble. When you differentiate e to the power of the bubble, it will be e to the power of the bubble. And then you times the derivative of the bubble itself, which will be 2x plus 0, which is just 2x. So now when you tidy this up, it will be 2x e x squared plus 1. So when you differentiate this, it will give you this thing here. You've got your x, you've got this e to the power of x squared plus 1, but you don't want this 2 because there is no 2 over here. So you would go back to your initial guess and stick a half in here. So now when you differentiate it again, this 2 would disappear, which is exactly what you want. So the final answer would be a half e x squared plus 1 and then plus c. So this is your final answer. Okay.